I'm Johannides, and my work is on purification of lipopeptides. Cyclic lipopeptides are a class of biosurfactants produced by many different microbes, but for our research and practical purposes, we chose to focus on bacillus species. Bacillus are rod-shaped, aerobic or facultative anaerobic, gram-positive bacteria that produce robust endospores. Sporulation is significant because it generally signals the onset of stationary phase that is characterized by production of antifungal compounds. The organism we've harnessed in the lab is B. amyloliquefaciens, which has shown itself to be effective against several fungal isolates due to secretion of ytterinic and fungicin lipopeptides during its secondary metabolism. The lipopeptide families produced during fermentation, which all have a cyclical structure, include fungicin, ytterin, and surfactant, and these are our target proteins. Ytterin and fungicin are particularly interesting to us because of their antifungal applications in the post-harvest value chain. Surfactant always causes reactor headspace issues because of its capacity to overproduce foam. The primary goal in this work is to separate the antifungal compounds, ytterin and fungicin, from the broth and surfactant, thereby generating a consistent, controllable product that could potentially be formulated and marketed to compete with commercial biocontrol agents. Some of the phytopathogens we'll be targeting include botrytis and penicillium species. The mechanism of action is thought to be this interaction with sterol components in the fungal membrane, which leads to potassium-ion leakage. Cyclic lipopeptides, or CLPs, can be precipitated out of spent media when the pH is several units away from the pI value. We mostly do this at acidic pH with the addition of hydrochloric acid to pH of 2. The low pH causes lipopeptides to become positively charged, reducing the effectiveness of the hydrophilic tail region and possibly causing aggregation. This renders the molecule insoluble and the compounds precipitate as a solid. Pre-concentration by acid precipitation is useful before more sophisticated techniques are applied for polishing the target proteins. Acid-precipitated CLPs can also be separated from contaminating salts by solvent extraction. Chloroform and methanol in various ratios represents the most flexible method for obtaining an ideal partitioning coefficient, but both solvents are toxic to human health and the environment. Solvents also tend to be quite expensive. We are looking at optimizing absorption using macroporous resins, but these are expensive and increase the number of unit operations in the process. Another negative is the concomitant absorption of other small molecules found in the broth. As an alternative to acid precipitation, some researchers have used aqueous two-phase partitioning as a primary means to enrich lipopeptides. It provides more interesting processing perspective with potential for efficiency and cost improvements, and the ability to overcome product inhibition during fermentation. We've begun testing high salt concentration modified growth medium to establish binodal curves and partitioning coefficients of the lipopeptides in question. Few attempts have been made to design systems in which liquid two-phase separation is directly coupled to culture growth and production, which we term extractive fermentation. But Duran and Cooper used PEG or dextrin to create a separate aqueous phase above growing cultures of Bacillus subtilis. They successfully extracted surfactant and observed that product removal had a stimulatory effect. We're also looking at novel solvents to see if they show potential for separation of biosurfactants. We've designed our own purification column to be used for flash chromatography. The idea is to separate and fractionate our own lipopeptide standards. However, this is proving tricky to optimize and is only useful for bench scale experiments and project scoping. In closing, although many of the methods for separating cyclic lipopeptides from spent media could be used in larger scale purifications, costs would need to be reduced by at least 2 orders of magnitude. In the meantime, significantly more research is required. Thank you very much for your interest and time.